We're now going to do a formal proof, and we're going to do it in paragraph form. And in this case, if you look at this particular proof, we have in the original diagram, notice we have overlapping triangles. So one of the things that you can do to make the problem simpler, or to help you in terms of your proof, is you can actually take those triangles and re-sketch them. So if you look down here, this is what I've done. I have markings on them, and I'll explain those in a minute. If you look right here, I have angle ABD is congruent to CBD. So I've just marked those in green. You could put check marks there, it's no different. I have angle CBD is congruent to ADB. So notice I've marked those two in yellow, and I'm trying to prove that AB is congruent to CD. So what I'm going to do is, immediately I can look and I notice that if these angles, two angles are congruent, and these two angles are congruent, basically if I can get one side congruent, then I can show the two triangles are congruent. So that's how I'm going to approach this. So I'm going to begin by looking at this side right here, BD, which is I'm going to mark, is a common side to both triangles. So I can actually say that BD is equal to itself. And sometimes you write it as DB. It makes no difference. You can write it in any order. In math, we call that the reflexive property. In other words, or you could simply say, if you're stating that, you could simply say that this side is equal to itself. And that would be good enough to say. I also have the angles in question that are equal to one another. So I have ABD is congruent to angle CDB, I'm sorry. And angle CBD is congruent to angle ADB. And that's just given information. Based on that information, I can say now that triangle ABD is congruent to triangle CDB. And the reason for that is because of the angle side angle theorem. And then finally, you can make the statement that AB is congruent to CD. And the reason you can say that is because of corresponding parts of congruent triangles are congruent. And quite often you will see, or that can be written in that form, or shorthand form. And so now your proof is complete.